This is one of our identities from, I lost my sheets. I printed off a whole bunch more, and I just, thank you though. I printed off a bunch more, so if you're missing your sheet, just come see me. There's a bunch more in my office. I'll bring them to class tomorrow. But what I'm saying is this is definitely one of those identities we just learned. So it's one of those sum and difference identities. I just need to match up which one it matches up with. So I'm looking at this. It goes sine, cosine, cosine, sine with a plus between it. That plus is important, and so is the order that those cosines and sines come in. So I'm looking for one that goes sine, cosine, cosine, sine, and it matches up to this one, our sine angle plus an angle. And that means that this is my alpha, this is my beta, so I come back here and I'm like, oh, they all match up. This is my alpha, this is my beta. That looks like an R. That's my beta, or B. That's alpha, that's beta. So going the opposite direction, I need to change it into sine alpha plus beta. But rather than putting alpha and beta, I'm going to put sine of my alpha angle is t, plus my beta, which is 2t. Add t plus 2t equals sine of 3t. Nice. So the correct answer was A, sine of 3t. Mercer, do you have these notes?
Yes.
Okay.
I just need to open. Sorry, I was looking at my thing earlier.
Okay. All right. Questions on bell work? Then let's do questions from the homework. Let's get this solidified. So I'm looking at 7.3b. I kind of think of these verifying ones as practice. So if you didn't have it done, I still gave you full points, but it's good practice. We're going to keep practicing these because these are like the big points on the test. Go.
13.
13. What's 13 asking me? Do I have it up here? Oh, it's always the tangent. Oh, it's tangent backwards, right? Yeah. But we should have realized something was off on this one. Because if I look at, okay, pi over 7, that's my angle. Let's call it A instead of alpha for now. This is my B. But here's the problem. In order for this to be A, it has to be the exact same thing. I'm also going to note, hey, tangent usually has an opposite top and bottom. So if I go back to my little thing here and look at tangents, well, if I have a plus on bottom, I have a negative on. If I have a plus on top, I have a negative on bottom. If I have a negative on top, I have a plus on the bottom. So both those things don't jive with this problem because right now I have a plus and a plus. So that tells me I need to get rid of this negative sign. And remember, for cosine and secant, you can just erase it. It becomes positive. For everything else, you can bring it out front. So for this negative sign, I'm going to bring it out front, which makes this a positive and makes this a negative. Now this matches, that this is my A value and this is my B value. Now it works just like our bell work. It's backwards. So tangent plus a tangent, well, that equals tangent alpha plus beta, which in this case would be our tangent of our first angle is pi over 7 plus our pi over 6. But we should go further. We should see what happens if I add those together, because maybe that's on the unit circle. Now remember, if I need to push two fractions together, one of the easiest ways is to multiply by the other denominator. That's good practice for identities. If I need to push fractions together, multiply by the other denominator. So this is going to be tangent pi over 7. I'll go through all the steps. Times 6 over 6. Plus pi over 6 times 7 over 7, which is going to give me tangent of 6 pi over our 42, plus our 7 pi over 42. Which equals, 12, wait, what did I say? 13 pi? Yeah, 13. I can't read my own writing sometimes. Over 42. Can we simplify 13 pi over 42? No. So that's just going to be our final answer. And is 13 pi over 42 on our unit circle? Nope. So we just leave it as is. Okay. Other questions? Are there any that I want to go through? Maybe not. Yeah.
Wait, so we don't have to worry about the bottom part?
Are we talking here or here?
Yeah, no. Yeah.
Right there? We do have to pull that negative out front. But notice now it matches exactly with that one identity. It says tangent of an angle plus tangent of an angle. It matches this one. If you look at tangent angle plus angle, it equals tangent angle plus tangent all over 1 minus tangent tangent. Our job is just really just like the bell work. Just figure out which one it matches up with and go backwards on it. Other questions? Preguntas going once, going twice. All right, 3 times. All right, we have 2 skills we have to talk about today. One we've already covered and one we haven't covered. So this might help us review certain problems that are going to show up on the test. So this is going to be similar to one we've done before. If you remember, we had a quiz on this. I would say something like sine equals 3 over 5. It's in quadrant 2. Find cosine using the identities. So I have to use the fact that sine squared plus cosine squared equals 1 to find my cosine value. We're going to need that today. Because today we're going to say, find the exact value of this. And notice how it's an angle plus an angle. We have to know to go to our sum identity. In fact, as soon as I see that on a problem like this, I'm going to write out the sum identity. So that's actually my first step. If I'm asked to find sine alpha plus beta, it means I need to write that identity in order to solve it. So I immediately go, oh, you know what, sine alpha plus beta, go to my sheet, find out that that's sine cosine plus cosine alpha sine beta. So your job is just to go, boom, write it out. So just for instance, we're not going to do it just yet, but if we look at the second example, it says find the exact value of cosine alpha minus beta. I bet you the very first thing I write out what cosine alpha minus beta looks like for my identity. That's our first step. So I write it all out. Now I continue reading. It says, given that sine alpha equals negative 3 over 5, cosine beta equals negative 1/3, and alpha's in quadrant 4 and beta's in quadrant 3. So we have 2 angles here. We have 2 angles here. One of them is in quadrant 4 and one of them is in quadrant 2. We will never know what the angle is. We're never going to say, okay, it's 35 degrees or it's 150 degrees. We'll never know the angle. But what we do know is that if I'm talking about alpha, I'm in quadrant 4. What's positive in quadrant 4 if I do my all students take calculus? Cosine or x values, yeah. So cosine's positive, everything else needs to be negative. If I'm talking about beta, beta's in quadrant 3, what's positive in quadrant 3? All students take tangent. Not too worried about this because none of these are tangents. Okay. Now I write this out. Now we insert information that's given to us. So they give me sine alpha equals negative 3 over 5. So we take that negative 3 over 5. I'm running out of colors. That's ugly. I'm going to take that negative 3 over 5 and plug that in for sine alpha. That's where I got that negative 3 over 5 from. Then I go, oh, you know what? Cosine beta is negative 1/3. I take that and plug that in here, and that gives me my negative 1/3. This is our problem. Realistically, this is our problem. Right now I have sine alpha plus beta equals negative 3 over 5 times negative 1 over 3 plus cosine alpha sine beta. The only thing we really have to do is we need to find what cosine alpha and sine beta equal. What do those 2 things equal? That's our whole job, is to find what do these 2 things equal. And we need to use identities to find these 2 values. So we're going to have a box for solving for cosine alpha, and we're going to have a box for solving for sine beta. Now, remember, we have an identity that connects sine and cosine together. In fact, I'm going to draw that up here. I'm going to say, you know what, at any time, I can say that sine squared alpha plus cosine squared alpha equals 1. Do we know sine alpha or cosine alpha? Do we know either one of those? We know sine alpha. So right now you could plug negative 3 over 5 in for here. That's what we did in the first lesson that we had this. If you played along with that lesson and you did well on the thing, you're going to follow along with what I'm going to do here. I'm going to shorten this problem just a little bit. I'm going to solve for cosine alpha without plugging any numbers in here. So in order to do that, what I'm going to do is I'm going to move the sine squared to the other side. That will give me cosine squared alpha equals 1 minus sine squared alpha. I'm going to take the square root of both sides, and cosine alpha is going to equal plus or minus the square root of 1 minus sine squared alpha. Now, you said we already know what sine alpha is, right? It says up here, sine alpha equals negative 3 over 5. So I'm going to go ahead and write that here. So sine alpha equals negative 3 over 5. We got that from up here. Now, we could take that 3 over 5, and we can either plug it in here, or you could have taken that negative 3 over 5 and plugged it in there. It's up to you. Depends on your comfort level of doing these. So we could plug it in right here, or we can plug it in up here. For this example, I'm going to plug it in here. For our second example, I'm going to plug it in the top one, okay? So we can see both versions of it. So I'm going to go ahead and take that negative 3 over 5 and plug it in there. So we're going to have cosine alpha. Don't write too big. We got a lot of stuff we got to kind of plug in this box. Equals plus or minus the square root of 1 minus a negative 3 over 5 squared. Notice how I'm replacing it using parentheses because this negative is actually going to get squared, which will make it positive. All right, real quick. We're talking about alpha, right? What quadrant is alpha in?
4.
It's in quadrant 4. What's positive in quadrant 4? So we should circle the positive option. So this is going to be a positive because we're talking about alpha and we're in quadrant 4. It says right here, anytime we're talking about alpha, we're in quadrant 4. Alpha, quadrant 4, we have a positive. So that's going to equal a positive square root. I'm not going to write the 1 yet. I'm just going to do the negative 3 over 5 squared, which would be 9 over 25. That way I can rewrite the 1 as 25 over 25, just to speed up that process a little bit. Marsha, do you not have the notes?
I do.
Oh, okay. You going to take some of them?
Yes.
All right. So that's just going to equal square root of 25 minus 9 is 16 over 25. Square root of 16 is 4. Square root of 25 is 5. So cosine alpha equals 4 over 5. So now we can put that 4 over 5 back into this problem. Now we have to find sine beta. So to do that, we're going to kind of do the same steps here to shorten it. So I can use the same thing with sine beta. I can go, you know what? Sine squared beta plus cosine squared beta equals 1. Move the cosine to the other side. That would give me sine squared beta equals 1 minus cosine squared beta. Square root of both sides, sine beta would just equal plus or minus the square root of 1 minus cosine squared beta. Now, once again, this is just a shortcut. Because if I memorize this, it's an easy way to go from sine to cosine or cosine to sine. It's really easy if you just remember it just as plus or minus square root of that. Do you have to use it? No. If this makes more sense to you, which we'll do in the next problem, then do it this way. But I'm going to use the shortcut method. Now, to find sine B, I have to know cosine beta. And we do know cosine beta. We know cosine beta equals negative 1/3. They gave us that. So now we take that and plug it in for that cosine value there. And so we're going to have sine beta equals plus or minus the square root of 1 minus, instead of cosine squared, we're going to replace that with negative 1/3 squared. What quadrant is beta in?
3.
It's in quadrant 3. Is sine positive or negative in quadrant 3? It's going to be negative because tangent's positive. Remember, that's why we do our all students take calculus. It tells you what's positive. Tangent's positive, so sine would be negative. So I need to use the negative portion of this because we are in quadrant 3. So we need to go negative with it. Okay. So that's going to equal a negative square root. I'm going to skip the 1. I'm going to square that negative 1/3, which would be 1/9. So I can change the 1 into 9/9. Nine minus 1, that's 8/9. So we're going to have this equals a negative square root of 8/9. So our sine beta is going to equal a negative, I'm going to tell you right now, square root of 8, 4 goes into it. So square root of 8 equals square root of 4 times 2. Square root of 4 is 2. So 8 reduces to 2. Square root of 2/3. All right, now we have to do is just take a quick nap and then be back up. Now we got to plug these back in. We got to plug those back into that original equation that we had. So we're going to take this, paste it right there. I'm going to do it right here, and then I'm gonna copy and paste it down. So sine alpha plus beta, they gave us the sine alpha and beta, so we're just going to write that negative 3/5 that we had on top times that negative 1/3. We are going to add, we now know cosine alpha is 4/5. We have our sine beta is going to be that negative 2 square root of 2/3. I'm going to pause for just a second while people kind of catch up. I'm going to copy and paste that and put it on my next slide. So I have a little bit of room to work. Now I just need to know how to add and multiply fractions. So I'm going to multiply numerators. I have 3 times 1, but first I have a negative times a negative, which will make it a positive. 3 times 1 is 3. So this will equal 3/5 times 3 is 15. If I did this correct, they both will have the same denominator. 4 times a negative 2 would be a negative 8. Square root of 2/5 times 3, which is 15. I can push these together. I cannot do the addition, or subtraction, I should say. So on the top of 3 minus 8 square root of 2/15. As a reminder, do not do 3 minus 8. It's connected to that square root of 2. We have to leave it as is, and that's our final answer. There's a lot going on there, right?
Yes.
Yeah. We'll do another problem. I didn't give us as much space because I want to show you that it really is just a simple process because I want you guys to get this stuff correct on the test. We're going to lose points on verifying. It's just going to happen. You're going to get stuck. Something's going to happen. These are ones that you can just practice and know how to do right when you get to it. This is one of those problems that we can just practice and get to the end of it. Luke, did you have your hand up?
Yeah. Can you explain to me again why we don't subtract 3 and the 8? Obviously, you said it because it's attached to the.
Because it's kind of. So PEMDAS says we have to do multiplication first before we do addition and subtraction, right? So I'd have to do this multiplication before I can do the subtraction, but I can't do this multiplication.
Okay.
It's kind of stuck in limbo, so I can't do that subtraction. Obviously, if we took our calculator and did 8 times square root of 2 and approximated it, then we could do the subtraction. But we'd have to do this multiplication first before I can do that subtraction.
Okay.
Maybe another example might make sense if I did like 3 minus 2x. Would you combine these? No, because they're not like terms. These are not like terms. I can't combine them.
The negative 8's attached to the root 2, right?
Yep.
Okay.
Yep. They're attached to that multiplication. Just kind of holds you there. Okay. Until you do it, you can't do addition. All right. Let's do our next problem. So this one says we're supposed to find the exact value of cosine alpha plus beta. Now, once again, this just kind of takes practice, understanding that I'm just asking you to write out what this means. So I'm going to take that cosine alpha minus beta. And I'm going to use my identity to realize that, okay, cosine alpha minus beta equals cosine cosine plus sine sine. You have an identity sheet. There's no reason for you not to be able to write this out. You are just copying down what's on a sheet that I'm going to give you on a test. And your sheet says cosine alpha minus beta equals cosine alpha cosine beta minus sine alpha sine beta. That's a point. All right? If this looks like a really hard, inaccessible problem to you, get that point. Just copy it down. I'm just asking you to copy something down. It should be a plus. I said that, didn't I? And then I wrote it. It should be a plus. Okay, thank you. I saw JP's little. All right, now our next thing to get some more points is understand that they're going to give you some of these values. Bless you. So they tell me sine alpha equals 1/3. So sine alpha equals 1/3. So we can take that 1/3 and plug it in for sine alpha. They also give us cosine alpha equals negative 1/3. So let's write what we have right now. So we know cosine beta, we know sine alpha. We don't know cosine alpha yet, so we'll leave cosine alpha alone. Cosine beta equals a negative 1/3, so we'll replace that with a negative 1/3. Sine alpha equals 1/3, so I'll replace sine alpha with 1/3. I don't know sine beta. And boom, we have some more points. So once again, if you think this is inaccessible to you, I'm telling you, you can at least copy this down and copy down which information is from you. That should be doable. That is without overthinking, just write down something, write down what we're substituting. Now, the real hard part is right now that I need to solve for cosine alpha. I need to solve for sine beta. So what I'm going to do is I'm going to kind of wall off where I'm at. I'm going to use this section to find cosine alpha. Now to find cosine alpha, we can just use the fact that sine squared alpha plus cosine squared alpha equals 1. In order to find cosine alpha, I must have been given sine alpha, which we were. That's 1/3. So if you're comfortable with doing this, we can skip to the box section. I'm going to do the longer method just because we haven't seen it for a while. So I'm going to take that 1/3 and I'm going to plug it in for that sine alpha right here, which means I suddenly have 1/3 squared plus cosine squared alpha equals 1. Square that 1/3. That will be 1/9 plus cosine squared alpha equals, I'm going to change that 1 into 9/9 because I am going to subtract that 1/9 from both sides, which will suddenly give me cosine squared alpha equals 8/9 because I'm going to subtract that 1/9 from both sides. That gives me 8/9. This is just algebra. Really, your big step was just understanding that you can plug that value in. So we just follow our algebra along. We get 8 over 9. Take the square root of both sides. Remember, when you take the square root, it becomes plus or minus. So now I have cosine alpha equals the square root of 8 over the square root of 9. I have to now decide if it's positive or negative. So they must have given me some information about where angle A lies. Where does alpha lie? Which quadrant is it? Oh, it says both angles are in quadrant 2. Quadrant 2, that's sine's positive, so cosine is negative. So that's going to be a negative 2 square root of 2 over 3. I'd actually be okay if you just left it as square root of 8 over 3 as well. Yeah. I have negative 2 squared, because this is plus or minus. I had to decide if it was negative or positive. So square root of 8 turns into 2 square root of 2. And it has to be negative because we're in quadrant 2.
So you can do either way, pretty much.
Mm-hmm. So this is just, I think you're talking about like the box method. That's just a shortcut. Because think about what this does. It takes the square root, it subtracts. It did everything I did here. It just did it for me. So I had to subtract. I had to take the square root. But either way works. This can be accessible for people that kind of struggle with this kind of stuff. And people that are really good with it tend to skip it and go to this one. But you do you. Whatever one makes more sense to you. All right, the last thing I need to find the, what am I left with? I need to find that sine beta. Sine beta must come from the fact that sine squared beta plus cosine squared beta equals 1. So it's the exact same method. Except for this time I know cosine beta equals negative 1/3. So we're going to take that negative 1/3, plug that in for my sine beta. I'm sorry, did I do that right? We need to plug that in for that cosine beta. Because it says cosine beta equals negative 1/3. Plug that negative 1/3 in for that cosine beta. All this is plugging stuff in. The hard part is to understand what you're plugging in and where. Ooh, that took up a lot of room for me. Okay, so now I plug that negative 1/3 in for that cosine beta. So now suddenly I have sine squared beta plus, use parentheses to plug in that negative 1/3, squared equals 1. 1/3 squared turns into sine squared beta plus, well, it's negative 1/3 times negative 1/3 equals a positive 1 over 9. Change that 1 to 9 over 9. Do our subtraction of sine squared beta equals 8 over 9. I will take the square root of both sides. Understand that it's plus or minus. Beta's in which quadrant? 2. Is sine positive or negative in quadrant 2? It's positive. All students take calculus. Student says sine is positive, so I'll take the positive. And we're going to have sine beta. Well, we did all the work on the other one. That should equal a positive 2 square root of 2 over 3. Now we take this one, plug it in for our cosine alpha. Take this one, plug it in for our sine beta, and we are done. So we found out cosine alpha equals a negative 2 square root of 2 over 3. So we'll put negative 2 square root of 2 over 3 here, times that negative 1/3 plus 1/3. Sine beta is 2 square root of 2 over 3. We are going to do our multiplication. This is a negative times a negative, which will give us a positive. So we'll have a positive 2 square root of 2 over 3 times 3, which is 9, plus a positive 2 square root of 2 over 9. If I have 2 square root of 2's and I add 2 more square root of 2's to that pile, how many square root of 2's do I have? I have 4 of them. So you can add them as long as they're like terms. And you can think of square root of 2's as being like terms. So if we keep going, this is going to be for square root of 2 over 9. I will point out there's a lot of places to make little mistakes, right? But I'm not going to try to nickel and dime you every single time. So if you make little mistakes, it's fine. This problem has a lot going in it. So you think it's going to be worth a lot of points on a test?
Yeah.
Yep.
Yeah. And it's doable. It is more doable than some of the verifying, because verifying you can just try things and you get stuck on this. This just takes practice. Practice is, when you see this, write this. Then put down information you know. Then use sine squared plus cosine squared to find the other stuff. If you make little mistakes along the way, cool. All right, if it's a lot of points, maybe you just lose half a point because you didn't quite get it right. Or I might just say, dude, you did almost all this right. You just forgot a negative sign. I'm just going to give you the points for this. So don't look at this as being inaccessible. Think of this as something that you need to do for this test, because it's worth a lot of points, and you don't want to lose points and stuff like this, because verifying is kind of hit or miss on whether you can do it. Sometimes you get stuck, sometimes you don't. Don't get stuck in something like this.
With verifying, it's a lot easier to think you're doing it right and you're not.
And all of a sudden you're not, yes. Where this is basically it's step by step if you practice it. All right, one more quick example. We're going to do a verify one. The only reason why I'm doing the verifying ones for these should be really easy. Your job with verifying when it's got a sum or a difference is to, no matter how complicated the right side looks, you have to do the sum or difference first. So no matter what it looks like, this has to be done first. Now, it's an identity. It's got an addition or subtraction, so that means they'll be provided for you on the test. All you have to do is copy down what your sheet says. So if it's cosine of an angle minus an angle, that's going to be cosine, cosine plus sine, sine. If you don't believe me, look at your sheet. It is cosine, cosine plus sine, sine. So this will just be rewritten as cosine of our first angle, which is x, times cosine of our second angle, which is pi over 2. Can someone explain to me why it's not negative pi over 2?
Because that's just subtraction of things that actually
Yeah, because this just tells us which identity to use. We're using the positive pi over 2. Okay, and then we're going to have a plus, because that's how cosine works, sine x, sine pi over 2. Now, here's different than any verifying that you've done so far. Cosine pi over 2, is that a value on our unit circle?
Yes.
What is cosine of pi over 2?
0.
That is just 0. What is the sine of pi over 2?
1.
Are we okay with 1? Mm-hmm. Okay, so that's 1. So really what we have is we now have cosine x times 0. What's anything times 0?
0.
So that's just gone. Plus sine x times 1. What's sine x times 1? Sine x. Okay. Does that match the other side yet? No. So now I stop. I'm like, okay, I did all this right. So let's look at the other side. The other side's in terms of cosine and tangent. What's something I can always do to help simplify the right-hand side? Yes?
Change tangent to sine over cosine.
Change tangent to sine over cosine. So we have cosine x times, we're changing tangent to cosine, sine over cosine. Oh, if we look, our cosines cancel out. We're just left with sine x, which matches, and we're done. Easy, as long as you realize that you have to do this first. It's hard for people that don't practice this stuff and don't go to their identity sheets and look stuff up. This is something different. You have to do it first. Kind of like, when we had negative angles in there, where I had like a negative alpha, you had to pull that negative out or erase it. You have to do those odd things first, and then do our more common things. Yeah?
Have we had a problem yet where we simplified both sides of it?
We did this one. A lot of times you can do it. And it depends on what method you used. So if you look at my answer key, some of them I did on both sides, and some of them I just did strictly on one side, and I could push my way through it. But this one's a very good one to have to work on both sides, because I know I have to do this first, But I'm also looking at this and I'm like, that tangent probably has to change too. So this is one of those that I'm probably going to have to work on one side, stop, and go to the other side. All right, questions on any